Okay, hello there. I'm presenting the study titled by Traffic Signal Coordination Between Two Intersections. For a street with successive signalized intersections, the signal controllers could be optimized as a system, a control strategy to determine a coordinated plan for optimizing the total network performance. For example, the delay is so-called coordination. The one-way road signal coordination is simple. If the vehicle meets the green light at the upstream, the onset of the adjacent downstream intersection is shifted as the travel time. The vehicle can pass without any stop. However, the two-way road coordination is much more complicated. The study can provide how the delay can be minimized to adjust the offset between two successive intersections with given travel speed, distance between the two intersections, common cycle time, and the green splits. On the top of coordination, let me introduce the concept of coordination effectiveness. When doing the parameter setting, if we can reduce the total delay for the whole system significantly, we can call the effectiveness is high or good. In other words, if the total delay is not sensitive to the parameter setting, it is the case of low effectiveness. To get deeper into the problem, we should know three basic parameters in advance: the cycle length, green time, and offset. The offset means the phase start time difference between two intersections. For exploring the principle of two-way control problem, the author suggested that we can start from only two intersections, A and B case. Suppose the same cycle length of two intersections. The through traffic demand is equal to the capacity, and we set the link length to make sure travel time with fixed speed. Cauchy in 1989 firstly discussed about the most simplified case that two intersections have the same green time equal to the half of cycle. Cauchy concluded that the coordination effectiveness will be highest when travel time is equal to the integral multiple of cycle length. And the lowest case is the integral multiple plus half cycle. And the highest case, we can get zero delay by finding optimum offset. But in the lowest case, whatever we change the offset, the delay will not change. Recently, the author of the study, Sakagibara and Oguchi, discuss two more generalized cases based on the Cauchy 1989. When the same green time is not half of cycle, the conclusion of Cauchy will not be changed. However, when providing different green time to the two intersections, in the highest effectiveness case, we can obtain not an optimum point, but a range of minimized delay. In the lowest effectiveness case, the delay is not always the same, but it becomes possible to get larger within some range of offsets. The study formulated the relationship of offset setting and delay in two intersection coordination control problem. However, the formula is based on the fixed demand, fixed speed, and only two intersection case. In the future, the author planned to further generalize the signal coordination formula into various demand scenarios in auto and not only the offsets but also the speed adjustment and the connected autonomous vehicle environments will be discussed.